Bismillah Rahman Rahim. I am your instructor Saira Khan for the course Application of Statistics in Psychology with course code 509. This is our lecture 7. This lecture 7 is very much connected to our previous lecture, lecture 6, in which we have discussed the concept of variability and learned two methods to measure this variability of the given set of data. This lecture is also about the measures of dispersion. Uh, Today we will discuss two methods of measuring the variability or the dispersion. One method is standard deviation and the other method is the variance. Actually, variability provides a quantitative measure of the difference between the scores in the distribution and describes the degree to which the scores are spread out or clustered together. In simple terms, we can say that if the scores in the distribution are all the same, then there will be no variability. If there are small differences between the scores, then the variability is small, and if there are large differences between the scores, then the variability is large. Variability or the standard deviation, which is one method of the measuring the variability, are mean and the standard deviation are two very important descriptive statistics of the given set of the data. They describe the set of that data and also standard deviation or the variability is an important component of most of the inferential statistics. In the case of descriptive statistics, variability measures the degree to which the scores are spread out or the cluster together in the distribution. And in the context of inferential statistics, variability provides a measure of how accurately any individual or the school represent the entire population. If the sample drawn from the population, all the individuals are having the same scores, then there will be no variability, and the sample will be the true representative of the population. And if the sample drawn from the population have some differences in the scores of the individual, uh, some differences, then there will be small variability. And if the sample, and it will be the representative sample of the population. But if the sample drawn from the population have the scores of the individuals, they have large differences, the variability will be large, and that sample, that individuals will not be the true representative of the population. That's why variability, the concept of variability or the knowledge of the variability is very helpful in describing the given set of data, and also telling about the representation of the sample as a true representative or the representative of the given population. When the population variability is small, all the scores are clustered close together, and any individual score or the sample will necessarily provide a good representation of the entire set of data. On the other hand, when the variability is large, the scores are widely spread, and it is easy for one or the two extreme scores to give the distorted picture of the general population. These are three distributions uh, of some set of data having the same mean. This center point of the three distribution is the same, but the variability of the three distribution is not same. uh, they are very different in the scattered score of the data set around its mean. The distribution scores in distribution are slightly different with each other and have the variability, but very small variability. And the most of the scores in this distribution are clustered around this central point, whereas the distribution B, mm, the individuals in this distribution have some scores different from very different from each other, have the extreme values in this distribution. uh, mm, so uh, the variability to some extent is large, and it may be have some representation with the population, but it is different from the population to some extent. In the same way, the third distribution and the large difference in the scores. That's why this is the distorted picture of the population. Measures of dispersion, we have discussed range and mean deviation in the previous lecture. Today we will focus on the standard deviation and the variance. Standard deviation is a statistic that measures the dispersion of a dataset relative to its mean. Standard deviation actually is the most commonly used and the most important measure of variability. Standard deviation uses the mean of the distribution as the reference point and measures the variability by considering the distance between each score and its mean. That's why uh, dispersion of the dataset relative to its standard deviation measures the dispersion of the dataset relative to its mean. In the simple terms, the standard deviation provide a measure of the standard or the average distance from the mean and describes whether the scores are clustered together around the mean or are widely scattered. And if the data points are further from the mean, there is the higher deviation within the data set. Thus, the more spread out the data, the higher the standard deviation. Standard deviation measures the standard distance between the score and the mean. Standard deviation, also abbreviated as SD. SD is the measure of variation or the variability. Although the concept of standard deviation is straightforward, and actual equations and tend to be more complex. Therefore, we begin by looking at the logic that lead to these equations. If we remember that our goal is to measure the standard distant from the mean, then this logic and the equations that follow will be remembered or can be understood easily. First step is the finding the standard in finding the standard deviation from the mean is to determine the deviation or the distance from the mean for each individual score. Uh, Deviation is a distance from the mean. Deviation score is equal to x is the data values, and minus mu is the mean of the population. From the distribution of the scores with the mu is equal to 50, if our score is x is equal to 53, then our deviation score is 3. If our score x is equal to 45, then deviation score is minus 5. Notice that there are two parts of the deviation score, the sign, which can be positive and negative, and the number. The sign tells a direction from the mean, that is, whether the score is located above or below the mean. The number gives the actual distance of the mean. For example, a deviation score of 26 corresponds to the score that is below the mean by a distance of 6 points. The second step is the calculation of mean of the deviation scores. To compute this mean, we first add up the deviation scores and then divide by n. We start with the following set of n is equal to 4 scores. These scores add up to summation x, which is equal to 12. So the mean will be equal to 12 divided by 4, which is equal to 3. For each score, we have computed the deviation. These are the x values, and now we will subtract this mean from each value of the data. 8 minus 3 will be equal to 5 plus 5. 1 minus 3 will be equal to minus 2. 3 minus 3 will be equal to 0, and 0 minus 3 will be equal to minus 3. We add up these division scores, which is equal to 0. Note that the deviation scores add up to 0. This should not be surprising because the mean serves as the balance point of the distribution. The total of the distances above the mean is exactly equal to the total of the distance below the mean. Thus, the total for the positive deviation, which is plus 5, is exactly equal to the total for the negative deviation, minus 2 and minus 3, which is equal to minus 5. Because the sum of the deviation is always 0, the mean of the deviation is also 0 and is of no value as the measure of the variability. Specifically, the mean of the deviation is 0 if the scores are closely clustered, and it is 0 if the scores are widely scattered. Our focus is to find the standard distance. For finding the standard distance from the mean, step 3, the solution to get rid of this sign, which is plus or the minus, the standard procedure for accomplishing this Uh, the standard procedure for accomplishing uh, is to square each deviation scores. The average of the deviation score will not work as the measure of variability because it is always zero. Clearly, this problem results from the positive and the negative values cancelling each other. The solution is to get rid of the sign is to square each value, each deviation score. Using the squared values, we then compute the mean squared deviation, which is called variance. Note that the process of squaring deviation scores does not more than simply get rid of the plus and the minus signs. It results in a measure of variability based on squared deviation, which is called variance. Variance equals the mean of the squared deviations. Variance is the average squared distance from the mean. Although variance is valuable for some of the inferential statistics or the inferential method, the concept of square deviation is not an intuitive to descriptive measure. The squared value become meaningful, however, if we take the square root of it. Therefore, we continue the process one more step to measure the standard deviation. This one step more is the fourth step for measuring the standard distance or the standard deviation of the given set of the data. This is the final step. Simply takes the square root of the variance to obtain the standard deviation. Which measures the standard distance from the mean. Standard deviation is the square root of the variance and provides a measure of standard or the average distance from the mean. So, the standard deviation is the square root of the variance. The figure shows the overall process of computing the variance and the standard deviation. Remember that our goal is to measure the variability by finding the standard distance from the mean. However, we cannot simply calculate the average of the standard distances because this value will always be zero. Therefore, we begin by squaring each uh, distance. Then we find the average of the squared deviation or the squared distances, and finally we take the square root of the variance or the average square deviation. Technically, the standard deviation is the square root of the average square deviation. Conceptually, however, the standard deviation provide a measure of average distance from the mean. We still not presented any formula for variance and the standard deviation. We should be able to compute these two statistical value from their definition. The following example demonstrate this process. Following example will demonstrate all this process which we have discussed in 4 steps earlier. Step 1, step 2, step 3 and step 4. The demonstration of this process will enable us to compute the standard deviation from the given set of the data. this is the set of data which have 2, 3, 6, 8, and 11. We have to compute standard deviation from this given data. For the first step, we will calculate the mean of the data points. The mean of the data points will sum up all these values, which will be equal to 30, and there are n is equal to 5, 1, 2, 3, 4, and 5. We'll divide it by 5, and which is equal to the 6. In step 2, we will calculate the variance of each data point. The variance of each data point is calculated by subtracting the mean from the each value of the data point. This is the deviation from the mean. Mean is 6, and this data point is 2. 2 minus 6 is equal to 4. 3 minus 6 is equal to 3, and the minus 3. 6 minus 6 is equal to 0. 8 minus 6 is equal to 2, and 11 minus 6 is equal to 5, and 2 minus 6 is equal to minus 4. The next step, the third step, is to square the variance of each data point from the step 2. We will take the square of each these value, square of 4, 3, 0, 2, and 5, and we will sum up all these values, which is equal to 54. Sum up, this is step 4. We'll sum up the square deviation values from the step 3. Then in step 5, divide the sum of the square deviation of the variance values from step 4 by the number of the data points in the data set. Okay, and this is the variance, which is 54, which is the total of or the sum of the square deviations, and divided by 5 minus 1. 5 minus 1 is the sample. Then taking the square root of the both sides, taking the which will be equal to the standard deviation, which is equal to 3.67. This is the calculation of standard deviation and the variance from the ungrouped data. Now we will calculate these two values, the value of variance and the standard deviation from the group data. Now we will calculate standard deviation, variance, mean from the given set of data, which is the group data. First of all, we will find the midpoints. Midpoints can be calculated by adding these two values and dividing it by 2. 54 plus 57, which is equal to, and divided it by 2, which is equal to 55.5. Then 58 plus 61 and dividing it by 2 will be equal to 59.5. Then 62 plus 65, which is equal to 127 and is divided by 2, which is equal to 63.5. Then 66 plus 69 and divided by 2 is equal to 67.5. Then 70 plus 73 and divided by 2 equal to 71.5. And 74 plus 77 divided by 2 is equal to 75.5. And then 74 plus 77 divided by 2 equal to 75.5. And 78 plus 81 divided by 2, which is equal to 79.5. Now the last one, 82 plus 85 divided by 2 is equal to 83.5. Now we take the product of each midpoint with its corresponding frequency to find the summation fx value, which is very much necessary to find the mean of this set of data. We will multiply 55.5 with its corresponding frequency, which is 5, equal to 277.5. Then 59.5 will be multiplied by 7 is equal to 4616.5. Now if we multiply 63.5 with 10, it simply will be equal to 635. Now we'll multiply 67.5 with 12, which is equal to 810. Similarly, we'll multiply 71.5 into 6, 429, .5 will be multiplied by 5, and this will be equal to 377.5. Okay, now 79.5, 79.5 and is divided by 4, equal to 318, and 83.5 will be multiplied with 1, and it will be 83.5. Now we will add up all these values, which will be equal to 3347. Okay, first value is 277.5, second 416.5, then 635, 635 plus 810 plus 429 plus 377.5 plus 318 and plus 83.5, which is equal to 3347. To find the mean value, we will divide this value by the summation f. 3347 is divided by 50, which is equal to 66.94, which is equal to 66.94. Okay, 66.94 is the mean of the given set of the data. Now we will subtract mean from each value of the data point. The first data point of this data set is 55.5. We will minus mean value from this value. So we will .5 minus 66.94, which is equal to minus 11.44, and we will take the mod and will ignore all the minus values. Okay, then 59.5 minus 66.94 equal to 7.44. We will ignore the minus sign. Then 63.5 minus 66.94, which is equal to 3.44. We will again ignore the minus sign. Then 67.5 minus 66.94, and this is equal to 0.56. Then 71.5 minus 66.94 equal to 4.56. Then 75.5 minus 66.94 equal to 8.56. Then 79.5 minus 66.94 equal to 12.56, and last one is 83.5 minus 66.94, which is equal to 16.56. To find the mean deviation, only the mean deviation, not the standard deviation, we can take directly the square of this mean deviation. If we find the mean deviation, then we will first divide this the mean deviation with its corresponding frequency to find the mean deviation. Okay, we will one by one multiply the value of each value of the mean deviation, this mean deviation with its corresponding frequency. Each deviation score will be multiplied with its corresponding frequency. First deviation score 11.44 will be multiplied by its corresponding frequency, and this will be equal to 57.2. Then we multiply 7.44 with 7 and 3.44 with 10 and 0.57 with 12, 4.56 with 6 and 8.56 with 5 and 12.56 with 4 and 16.56 with 1, and take the sum of all these values, which is equal to 287.36. To find the mean deviation, we will divide this value, which is the summation f x minus x bar mod. We will divide this value with the total of the frequency, which is 50. When we divide this value with 50, we can get the mean deviation of the given set of the data. Our goal is to find the standard deviation of the given set of the data. To find the standard deviation and the variance from the given set of the data, we will take the square root of each deviation score, x minus x bar. So we will multiply this value with its corresponding x value, corresponding x minus x bar means deviation score. $57.2 will be 57.2 will be multiplied with 11.44, which is equal to 654.368. We will multiply each value of this column with its corresponding deviation score to find the square of each deviation score. We will multiply 52.08 with 7.44, and then 34.40 with 3.44, and 6.72 with 0.56, 27.36 with 4.56. So we will multiply 42.80 with 8.56 and 50.24 with 12.56, and lastly 16.56 with 16.56. This column containing the summation f, when we sum of all these values, we will get summation f x minus x bar square. So we can find the variance by dividing this value, summation f x minus x bar square, with the total of the frequency. We will the total of this column, which is equal to summation f x minus x bar square, is 2560.32, which will be divided by 50. Equal to 51.02064. This is the variance. and the standard deviation is the square root of the variance. When we take the square root of 51.5, we will get the standard deviation, which is equal to 51.2064 is equal to 7.155. 7.155 is the standard deviation of this given set of data. So what standard deviation tells us? Standard deviation tells us how spread out the data is. It is the measure of how far each observed value is from the mean. In any distribution, about 95% of the value will be within two standard deviation of the mean. Importance of standard deviation: things like height of the people in a particular population tend to roughly follow a normal distribution. Standard deviation are important here because the shape of the normal curve is determined by its mean and the standard deviation. The mean tell where the middle and the highest part of the curve should go, and the standard deviation measures the spread of the data about the mean value. Mean and the standard deviation as a descriptive statistics. If we are given numerical value for the mean and the standard deviation, uh, we can be able to construct a visual image or a sketch of the distribution of the score. As a general rule, about 70% of the score will be within one standard deviation of the mean, and about 95% of the scores will be within the distance of two standard deviation of the mean. The mean and the standard deviation are included in the text of an article. For example, the researcher might write the mean number of the dreams in the last week for the 10 students was 6, with the standard deviation 2.572. The mean and the standard deviation are also often listed in the table, especially if a study includes several groups or the several different variables. Mean and standard deviation also reported with the inferential statistics, t-test and ANOVA. The mean and the standard deviation are very commonly reported in a research article. However, the mode, median, and the variance are only occasionally reported. Sometimes the mean and the standard deviation are included in the text of the article and tell us about the central location of the data and the spread of the scores. And these are the references from which this all data has been taken. As the reference, we can also consult these books and these websites for more detail. So today we learned the two methods of finding the dispersion of the variability, which is variance and the standard deviation. Uh, so we totally learned four methods to find the standard deviation, variability or the dispersion. First one was the range, second one the mean deviation, and standard deviation and the variance. We have practiced all these three methods of finding the variability or the dispersion of the given set of the data. In the last example, we find the mean deviation and the variance and the standard deviation. We will practice these all methods inshallah in the class. Okay, Allah Hafiz.